Hi everyone, welcome to this session titled What's New in Snowflake for AI and ML. Thank you for joining us. My name is Sandeep Gupta and I'm a product manager in Snowflake in the ML team. And joining me in this talk today are my colleagues Puneet Lakhanpal, Nathan Wiegand. So this is the agenda of what we'll be covering today. We'll start by looking at what makes the Snowflake Data Cloud a powerful foundation and platform for all of your AI and ML workloads. We'll talk about some specific capabilities and features for data science and ML development and deployment in Snowflake. Then we'll cover some exciting new offerings in the generative AI and LLM space. And we have some great demos lined up for you to show many of these new features. So let's get started. So we know that Snowflake as a data cloud offers many key benefits of security and governance, scalability, flexibility, and this is true not just for your data warehousing needs, but it carries over to all of your ML workloads. So you can take advantage of Snowflake's unified governance, not just for your data, but for all of your ML artifacts, such as features, models, and applications. You can use Snowflake's elastic compute capabilities to process data, to train models, and run inference, all right next to your data, therefore eliminating the need to move data around or create multiple siloed copies of your data. So now let's look at some specific capabilities for data science and ML on Snowflake in more detail. So this slide shows a full overview of Snowflake's unified, secure, and scalable platform for machine learning that takes you all the way from development to ML ops to ML applications. Underlying everything is our optimized storage for a variety of data types and formats. In addition to this, you have access to the growing Snowflake marketplace, where you can tap into data shared by other companies or by our partners, as well as you can share and monetize your own data. On top of this is our flexible and scalable compute layer, which is in the form of our virtual warehouses. And now, with the addition of Snowpark Container Services, you also have the ability to run containerized applications on different types of clusters, including those with GPUs. Built on this storage and compute is the Snowpark Extensibility Framework. And this lets you write Python code and run it efficiently and securely inside Snowflake. Our ML APIs are an added layer that are used with Snowpark, and these can be used for data preprocessing, for feature engineering, for model training, as well as libraries for managing ML models and features. And lastly, we have prepackaged ML functions for the analyst users, as well as Streamlit-based application development framework. So this is sort of the full picture of everything for ML in Snowflake. Now let's take a look at what's new in Snowflake for data science and ML. So we continue to invest heavily in the AI ML ecosystem, and we are thrilled today to share with you a set of announcements that simplify, accelerate, and scale end-to-end AI ML workflows. So in the next few slides, we'll cover each of these in a little bit more detail. So starting with Snowflake Notebooks, this is a new product for interactive development using cell-based execution for your Snowflake data. It supports both SQL and Python, and it has powerful data visualization capabilities that are built on Streamlit chart elements. Plus, because it's integrated with Snowflake, it has all the benefits of Snowflake Security and RBAC, and then also Snowpark and Snowpark ML, along with a very large set of packages from our secure Conda channel, all come pre-installed, so ready to use out of the box. Our notebook product is now available today in private preview. Switching over to the modeling API, at Summit this year, we announced a new ML modeling API in preview. This API lets you run popular frameworks such as scikit-learn and XGBoost natively in Snowflake. So you get all the improved performance and scalability with distributed execution of many preprocessing functions that are available in scikit-learn. And you can also use all of the popular ML algorithms for training models using this API without having to manually write and package your code as stored procedures and UDFs. Everything executes natively in Snowflake, and the code looks and feels exactly like it would with scikit-learn and XGBoost. In addition to helping develop models, Snowpark ML also supports managing and deploying ML models. And the central part of our ML ops solutions is the Snowpark Model Registry, which is a unified repository of models packaged with all of the metadata for managing these models and managing their deployments. It supports not only models trained in Snowflake with Snowpark ML, but it also supports a wide variety of models from external tools as well as from open source repositories. And it packages all of them into a standard model entity in Snowflake and provides easy to use APIs for deploying these models to create inference endpoints. And these inference endpoints could be UDFs that run in the warehouse, or they could be run through the container service and packaged as a containerized application. You can also use the model registry to track model versions, to store and look at metrics associated with models, and get sort of full lineage and tracking of model ops. Also, on the ML ops front, we have a new integrated solution for helping users to create, manage, and serve ML features, both for use for training as well as inference, using the new Snowflake feature store. Our feature store helps organizations maintain a single source of truth for all of your features. It helps automate updating features continuously and consistently on new data. And it has a convenient Python API, which can be used along with the Snowpark ML library. The feature store is also integrated with the model registry, which means that when you track your model metadata, it is aware of the features that were used and it links between the feature metadata and the model metadata. Snowflake Feature Store is now available in private preview. So now I'll hand it over to my colleague Puneet to show you a demo of all of these capabilities.
Hi everyone, good afternoon. My name is Puneet Lakanpal and I'm the field CTO for data science here at Snowflake. Today I'm going to be walking you through a demo of end-to-end how you can use Snowpark ML for modeling in the new interface that we have called Snowflake Notebooks. We will also be exploring logging and versioning those models that are being developed using Snowpark ML in Snowpark Model Registry. So for the demo, what we have is we have a scenario where we would like to predict whether some financial transactions are fraud or not. So to do that, we will be essentially assuming the role of a Snowflake data scientist, and we will be using Snowpark ML to develop an end-to-end model. So first of all, for this particular data set, we have accounts data, transactions data, and customer data. We have around about 100,000 records that we will be exploring for modeling in this exercise. So you can see some sort of data elements over here. So for accounts, we have some transaction limits. For transaction, we have some details around who was the sender, who was the receiver, if that particular transaction was classified as fraud or not. And for the customer information, we also have some information if it is a preferred customer, if it is, what's the first name, what is the last name of the particular customer. So in order to do this end-to-end machine learning, first we will do some data preparation that would be pushed down using Snowpark right within Snowflake Notebooks. So what Snowflake Notebooks really does is it allows us to basically look into either documenting some details around what the task that we are doing in some sort of markdown cells. It also allows us to code in Python as well and see the results as we are interacting with these particular notebooks. So in this particular exercise, what I would like to do is I would like to use Snowpark for pushing down data preparation down into my Snowflake account. In order to do that, Snowflake Notebooks makes it really easy for me to basically pick those particular packages from this particular package picker. As you can see, Snowpark Python package it's already loaded by default. And I also have a few other packages that I will be using for my machine learning exercise. So for data preparation, what I'm going to do is I will be first looking at basically those accounts tables, those transactions tables, as well as the customers tables. I will basically be computing some features on top of the transactions tables, things like the hour of day or the date that I would be needing to extract out from my time information. I will be joining two different tables together, the transactions and accounts, using Snowpark. And at the end, I'll also be finalizing these final transactions by joining the transactions, the accounts, and the customer information together. So all said and done, the transaction data set size at the end of this would be about 100,000 records. And all of this is being pushed down using Snowpark into Snowflake so that no data is actually coming from a Snowflake database into these Snowflake notebooks. This is what the final transaction looks like. And essentially, you can see that some of these particular records are fraud, some of these are not fraud. And in order to kind of show the end-to-end machine learning exercise, I would also execute this notebook end-to-end so that you can see this in action. So you can see that there is a nice mini map towards the side, which basically tells us what particular cell we are on currently. And it also allows us to basically mark those particular cells as well. So while I'm actually going through this now, before I go into building the machine learning model, I would also like to explore how my data set looks like. So within Snowflake notebooks, we can use Streamlit charts to basically plot what type of distribution of those features look like. So for example, if I would like to bin these particular records, find out how many number of count of records there are per feature that I'm interested in, essentially I can do that very easily using Streamlit, right, within the Snowflake notebooks. So for example, over here, we can see that around a daily count of around 3 seems to be the highest number of count of records. I also see that the maximum number of transactions are happening between the hour between 10 to 15. And most of these customers that I have in my sample set around are not preferred customers. I can also see that some of these transactions, in fact, most of these are either coming from Philippines or they're also coming from Ukraine as well. Now let's get into the feature engineering. So what Snowpark ML modeling API provides us for us is it provides a way for us to use popular frameworks like scikit-learn or XGBoost to do some pre-processing at scale pushed down into Snowflake. So it has some very nice features around, like if you want to do some min-max scalars or one-hot encoders, you can easily do that on top of Snowpark ML, all pushed down into Snowflake. Also, if you want to use simple algorithms such as scikit-learn, or if you want to do some XGBoost-based model training, you can do that right on top of Snowpark data frames using Snowpark ML. So now what I'm going to do is I'm actually going to use Snowpark ML to do some pre-processing on these features. So for example, if I like to do some min-max scaling on these features, as well as if I want to do some one-hot encoding on these particular features, I can very easily do that with Snowpark ML. All these feature engineering are being pushed down into Snowflake without needing that data to be brought down into the Snowflake notebooks. So all the data stays in, and this processing is being done in a distributed fashion, right pushed down into Snowflake. So once my feature engineering is done and my training data set is ready, I can again see the data set and see what has done to my features, and I can very easily again plot these features and then see like what the distribution looks like. We can also very easily see the correlation between these particular features. So for example, Snowflake ML modeling API provides very nice interface to do correlation, and we can plot these correlations very easily as well. So for example, if I would like to see what is the correlation between fraud and the transaction utilization norm feature, essentially that seems to be a correlated feature, and so on, we can see the correlation between the other features as well. Now let's get into the hyperparameter tuning. Once my data set has been ready for model training, I can very easily use Snowpark for model training, as well as we can use Snowpark ML to basically do XGB classifier model building, as well as use grid search CV that comes out of the box with Snowflake ML. So in this particular exercise, I'm actually going to iterate over some estimators as well as learning rate, and we will be using Snowflake ML modeling's grid search CV to do hyperparameter tuning. So as you can see, the training time is done in about 15.3 seconds, and we can very easily do some evaluation as well using Snowpark ML. So once the hyperparameter tuning has been completed, we can analyze those grid search results and then calculate the F1 scores, the recall scores, precision scores, and plot out what were the optimal parameters that resulted in the best ROC AUC score. So for example, it basically is noted here that 0.998 is essentially this particular feature that gave the best number of results. Now we can also print the best model, and from all these hyperparameter tuning, we see that the XGB classifier with a learning rate of 0.2, was found to be, as well as the number of estimators 50, was found to be the best estimator. We can also plot the feature importances, and it seems that based on this data set, the hour of the day when the financial transaction is happening seems to be the best feature to predict if any fraud is happening or not. Now, since we have basically gone through this particular iteration of model building, we would also like to log these particular models inside of Snowflake, and we need a way to log these models. We need a way to version these models and keep a track of all these metrics that we have been coming out with these particular models. So for that, we have Snowpark Model Registry, and What that is it's Snowflake's native solution to basically deploy these models, manage these models, keep track of all these different versions of the models, as well as the associated metrics, all within Snowflake in a secure and governed manner. So essentially, we can see that for the particular model that has been trained, we can very easily log that model using registry.log model. We can also track all these metrics that were trained right inside of the model registry. So this example shows that for this particular name of the model, which is financial fraud detection classifier, there are multiple versions of the models that are available inside of Snowpark model registry. It also shows the unique IDs of those particular models, and all those models are being tracked along with their metrics right inside of Snowpark model registry. From this model registry, what we can do is we can get the best model based upon the score that we have defined. And once the model has been received, which was the best model, we can very easily deploy the best model on our Snowflake warehouse for inferencing as well. That is just one command away from going from a model registry into deploying on top of a warehouse using registry.deploy. Once the model has been deployed, we can get the reference back from the model registry using this particular command, and then we can very easily make the predictions on that particular model in a batch format and see which of these particular transactions are fraud or not. So this basically goes end to end through how we can use Snowpark ML to build the features that are needed to train the models. We can log the models. We can do iterative feature engineering on this particular process. We can train the model using Snowpark ML. And also at the end, we can deploy the model using the Snowpark model registry right on top of the Snowflake warehouse. And all of that experience is powered through Snowflake notebooks, which makes this process seamless end-to-end using Snowpark ML. So once we have predicted if the particular model is fraud or not, our job is done as far as a data scientist goes. But essentially, if I would like to share this notebook, generally the data scientists have to go through a lot of trouble doing so. So Snowflake Notebooks makes it really easy to share the notebooks with other data scientists or people on the team. So all of this is powered by role-based access control. And as long as the next data scientist also has the same role through which this particular notebook was built, it's very seamless where he would just log in and there will be the notebook that would be there ready to basically be seen as well as edited and also run as well.
Hi everyone, I'm Nathan Wiegand here. I'm a principal software engineer at Snowflake, and I work on Gen AI and LLMs. Here is the functionality available to you to get the most out of generative AI on your enterprise data. And you can see how you can use all of the available components to either quickly use AI within seconds or build custom apps as fast as minutes. In this session, we're not going to dive deep into the out-of-the-box LLM-powered experiences such as Document AI, Snowflake Copilot, or Universal Search. If you want to learn more about those and see other demos, make sure to check out the session on LLM for analysts and SQL developers. In this session, we're going to focus on the custom development, starting with how you can build LLM apps in minutes. At the core of all of this is Snowflake Cortex and Streamlit. Let's dive into each of these before we do a demo. Snowflake Cortex is an intelligent, fully managed service that hosts industry-leading AI models, LLMs, and vector functions. You can use it to quickly and securely analyze data and build AI applications contextualized with your enterprise data. Use it by accessing the power of Snowflake Cortex via serverless SQL, Python functions, or as part of LLM-powered experiences such as Document AI and Snowflake Copilot. Snowflake Cortex analytic functions are serverless SQL Python functions well suited for unstructured text analysis and predictive analytics. We also support structured analysis via our ML-based functions. Use it to receive specific outputs from unstructured text in a cost-effective way using smaller task-tuned language models, or generate prediction and insight on your structured data using our ML-based forecasting models. Use SQL Python functions in Snowsight or expose a custom app via Streamlit. Cortex app functions are serverless SQL or Python functions that run inference on conversational LLMs and execute vector search functionality. Quickly build contextually enriched applications using RAG by combining cutting-edge LLMs such as our own text-to-SQL and Meta's Llama 2 with vector embeddings and similarity functions. use SQL or Python functions in Snowsight, or expose as a custom app via Streamlit. Streamlit is an open source Python library for app development that's natively integrated into Snowflake for scalable, reliable, and secure deployment. Turn data and AI ML models into interactive applications that empower stakeholders to self-serve insights and gain trust in results. Use side-by-side code editing and the preview pane to add and remove components, then share the app URL with coworkers in one click.
Hi, I'm Dash, lead developer advocate here at Snowflake. Today, I'm super excited to show you how to use Snowflake notebooks, and more importantly, how to run LLMs using Snowflake Cortex. Let's get started. So for this demo, I'm going to use call transcripts as my data set. And I'm going to use Streamlit and Snowpark libraries from Snowflake Anaconda channel. But if I wanted to, I could have installed more libraries or packages right from here. Now I'm going to go ahead and run this cell first. In Snowflake notebooks, you can write SQL, Python, or Markdown, which is pretty cool. Now let's first review the data using SQL. There we go. And I can also double click on here to get the preview of the entire value for the column. Now I'm going to go ahead and run the exact same SQL, but using Snowpark Python. And you see that the output is exact same. So natively, you can write Python or SQL within Snowflake notebooks, which is pretty neat. All right. Now, notebooks also have native support for Streamlit. So I can use that library to visualize the data. Even if I'm not a Python expert, I can still build these charts in a Python cell because I can use SQL to get the data and then pass the data frame into Streamlit bar chart library. I'm going to go ahead and run this cell. And then boom, there you go. Now let's compare some LLMs. And first, I'm going to use specialized function called translate to translate transcripts from German to English. I'm going to go ahead and run this cell for that. And there we have it. So here's the translate function that I'm using, passing in the transcript, the from language, and to language. And here's our translation. Now let's see how we can use general purpose function called complete using the Llama 2 7B model with a very basic prompt. Now, you'll notice that because it's not tuned for that particular task, it's taking a little longer. And also note that the output, when it generates it, it will contain some additional text besides the output that we asked for right here. So at the top, you'll see some extra text before the translation begins. Now, this could be a problem if you're relying on the output to be strictly JSON. Now, let's do a little bit of prompt engineering using the prompt to build custom summaries from unstructured data. So you'll see that I've defined the prompt and then two different variables that will just hold the name of the model we want to use in the following SQL statements. Now let's go ahead and use Llama 2 7B model first and see what the output looks like. One of the things you see here in the 7B model is that the response includes a repetition of the prompt, which is not good if you really want to use the output as strictly JSON. I'd have to do some custom operations to remove that first part of the response and then process the JSON data that's being output here. Now let's try the same prompt on 70B model and see what the output looks like. Notice that it fully understood my request of providing the output in JSON format. And now I can use ST-JSON to print the output in JSON format. Now Llama hasn't been trained on my internal data. So a way I can have Llama answer questions about my data without having to do any fine tuning is using retrieval augmented generation, or RAG. Let's try that out. Well, first, let's see what my unstructured data looks like. So for that, I'm going to go ahead and run this cell. As you can see, there's a lot of information about the products and suppliers. Now I'm going to run this next cell, which will embed the text into vector format and describe the table so that we can see what the new data type looks like for that column. Okay, so now to put it all together, now for anything that I want to know, the function takes in the question as the prompt, converts that into embeddings using embed text, and retrieves the most relevant information by using one of the vector distance functions in Snowflake Cortex. In this case, I'm using vector L2 distance. And in just a few lines of code, I can now have conversation with my wiki. So I'm going to go ahead and run this, and we'll see what the response is based on our question. Who are the suppliers of Ski Max Pro 9000? And the answer is Mountain Gear Co. Now, I have this function which I can turn into a chat app using Streamlit in Snowflake. Let's see how easy that is to do. So here's the Streamlit in Snowflake application. You can see on the left, I've used Streamlit and Snowpark Python libraries to write this application. And down here, you will see that I'm using the exact same SQL we just saw in the notebook. And for the chat interface, I'm using Streamlit's chat component. Now let's ask a couple of questions to our wiki and chat with it, if you will. The question one we're going to ask is, who makes Dryproof 670 product? Alpine Equipment Company. Now let's find out what other products does this company supply. There you go. Just like that, we have an awesome interface and we can chat with our data or wiki by writing just a few lines of code. And that's it. Thank you for watching. Now let's learn more about how to build more complex applications using Snowpark Container Services.
Snowflake Cortex and Streamlit are great, can cover a wide range of LLM app scenarios, but we understand that sometimes you need more flexibility. This is where Snowpark Container Services come in so that you can bring your own, whether it's by fine-tuning an LLM or building a custom UI with more advanced front-end programming. Snowpark Container Services enables developers to easily deploy container images in Snowflake. This provides the ultimate flexibility because developers can run code written in any language, as well as choose from either CPU or GPU-based instances. Snowflake makes it really easy by making it all part of a single experience with a unified registry, elastic compute, and managed clusters. And it is also the place where you can bring entire containerized partner applications from the Snowflake marketplace. And as said, one of the great things about the Snowpark Container Services is that it becomes the infrastructure that lets you securely deploy a wide range of partner tools and platforms in your account. With that, let's see how you can use Snowpark Container Services to build your own LLM app.
Now let's see a demo of how we can adopt GenAI and LLM in hours right within Snowflake. So what this demo is essentially building a Snowflake search documentation right within Snowflake using a large language model, which is a Llama 2 13 billion model right inside of Snowflake's governance boundary. So what this requires is some sort of not just loading these large language models, but also a retrieval augmented generation-based pipeline right inside of Snowpark Container Services. So let's define what is RAG, or retrieval augmented generation. So let's say a user and I have this particular front end, and this particular front end allows me to ask questions to the large language model. So if I have a standard question like, if I start asking the question like, what can you tell me about Snowflake Data Cloud? The model does a good job because it's been trained on open source data. And then it basically says that Snowflake Data Cloud is a cloud-based platform and it enables organization and store. But then this seems to be reasonable, and we can actually monitor the feedback from the users as well, and basically submit that feedback back into Streamlit. And this particular Streamlit app is deployed right inside of Snowpark Container Services, which is our platform to not only have the Streamlit application, but also work with the GenAI LLM applications. Now, instead of asking a generic question, let's ask this question, which is very specific in terms of cost and billing. So let's ask this question, which is, what is the purpose of the warehouse metering history table function in the context of warehouse management? The large language model is hallucinating here a little bit. What you're saying it is basically this particular table contains information about the CPU and memory for a specific time range. Essentially, that is not true. And the model seems to be hallucinating in the sense that it's just making up answers. So while we're monitoring these models, essentially the users can easily say, this is not working, and then they can submit the response. And in terms of Streamlit, we can very easily see that the responses are not working out, and you can track the metrics as well. But let's see how we can make this process better. So when a RAG is built, what essentially is needed is, in order to make the Llama model respond better to the questions that are being coming from the user, we can send in some specific context about Snowflake documentation to that particular large language model so that it has some context as to what it has to respond to about. So let's ask the same question that we just asked to this particular Streamlit app. And as you can see, it did a good job trying to figure out what were the sections from the Snowflake documentation as the context. And that particular documentation was sent to this large language model. And essentially, it specified that, yes, return the hourly credit usage for a single warehouse for a specific time range. It basically calls out that it functions, returns the credit usage within the last 6 months. So now it's doing a much better job answering the question what the user has asked. Now, if you see how this RAG is built is, generally, you need a particular embedding model to convert whatever the user has asked into a set of numbers. So those particular numbers can help define a particular index on all these particular documentation, and then an embedding model essentially, and as well as accompanied with the index, does a good job trying to rank what those particular documents are. And based on the top search results, those particular search results are actually sent to a large language model as well. And then the LLM responds based on those particular answers. So in this particular component, there are two types of models that are being used. One is the embedding model, and another one is the large language model. Now, in order to fine-tune the embedding model, essentially, that is a process that actually helps a lot, because now if you fine-tune the embedding model, that particular model would act better in terms of stack ranking what particular document should be sent to the large language model, so that the large language model has a better context. And that particular app is on this one, where the fine-tuned embedding model is being used to send a better context in the large language model, and then the large language model will use that context to spit out the results. So now if we ask this question again to this better model, which is sending a better context in the large language model, it would have some additional details as to, like, it has some information about the query history, as well as like some additional details around, like, when, what caution should people be using in terms of figuring out the actual credits from Snowflake warehouses. So now, having a look at all these three different apps, now let's get into how this particular demo was built. So what has been done is, on top of Snowpark Container Services, Ray as the open source framework has been deployed. And Ray is a great open source framework because not only it allows us to basically parallelize whatever we're doing with these large language models, such as, if you want to calculate these embeddings, you can do that in parallel. You can have multiple GPUs that are sitting up in clusters of different sizes being available to calculate those embeddings in parallel. In addition, you can also use it for, fine-tuning the models, as well as you can have these models deployed as APIs as well on top of RayServe. So RayServe actually helps deploy these particular APIs and make those APIs available for production scale, because it allows things like dynamic request batching. It makes creating these number of replicas very easily. For example, if we take the same large language model, which is powering all these three different Streamlit apps, that is a Llama 2 13 billion model. And essentially, that particular model is not only a very heavyweight model, but basically deploying that as replicas requires, a lot of GPUs. So on this type of, with RayServe, in addition to an approach called as VLLM-based Ray approach, so you can very easily deploy this particular large language model. Really need those, heavy GPU machines such as GPU 7s or GPU 10s, because they are very hard to procure. But you can very easily deploy those particular big models on top of RayServe using simple, GPU 3s as well. So in this case, what I've done is I've deployed this large language model on top of RayServe with the help of VLLM, with 4 shards in parallel for those tensors. So you can see these, this particular API, as well as other APIs, which are also deployed for calculating those embeddings, as well as another API for fine-tuned embeddings as well. So for each of these embeddings APIs, as well as the large language models, 2 replicas have been set up to empower the application. So having a look at all these particular cluster information, as you can see, let's get into how this particular application was built. So in order to build something like a knowledge-based search, as I said, we need to start with basically chunking the data. So how this was done was, first of all, Snowflake documentation was downloaded from a sitemap. And once it was downloaded, all those documentation is now available as HTML files. Now we need to parse through all those HTML and convert that into text. So for that, what I'm going to do is I'm actually gonna use a library called Llama Index, which helps me not only convert that documentation into documents, but it also helps us convert those documents into nodes with a better chunking strategy. And in order to calculate the embeddings for those texts, I'm actually going to be using a GTE-based embedding model, which allows us to convert that text into numbers. And I will be using a FIAS. FIAS is a vector index, which allows us to store these embeddings and then locally, and then we can serve it using RayServe, as I showed previously. So let's actually run this and see this in action. So as I said, I'm using Llama Index to convert those particular documentation into chunks. And once it initializes, it basically spits out that Ray has been used in this. It also prints out like there are about 19 GPUs that are available. In this particular setup, there is one Ray head node, and there are about 10 Ray workers, all of type GPU 3s, which is the smallest possible GPU that is available. And that is the benefit of Ray, where you can distribute all this processing at scale. So what it does is it basically chunks all this information into Llama Index documents. As you can see, it is converting those documents into chunks, and it's doing all of this stuff in parallel. Once this is done, when the nodes are ready to be converted into embeddings, Ray would actually use the GTE-based embedding model, and then it would basically, on each of those chunks, embeddings will be calculated in parallel, and we can define like how many number of actors do we need for converting those texts. So the process for embeddings would be started now, and essentially once it starts, you will be able to see that there are about 4 out of 19 GPUs are running in parallel, and you can see this in action as well. So if I refresh this particular dashboard, you see 3 GPUs here in action, as well as 1 more GPU down here, which is being used to calculate these embeddings in parallel. So right now, out of 1,500 HTML files, Ray converted that using Llama Index into about 43,000 chunks, and each of those chunks are being processed in parallel with 4 GPU actors to calculate these embeddings in parallel. So once these embeddings have been calculated, we will be using FIAS vector index to store those embeddings and basically use those particular vector index to empower our RAG applications. As you can see, this particular process was done in 54 seconds, which is very fast, and then it didn't really use any heavy GPU machines as well. So after seeing what is possible using Ray on calculating these embeddings, let's actually fine-tune the embedding model, which is what was used in this third application. So fine-tuning the embedding model is also pretty simple. What we all need to do is essentially, basically go through the same steps that we actually had to convert those documents into chunks using the Llama Index library. And then essentially down here, we are using the Llama 2 13 billion parameter model to essentially spit out like a training and a validation test set. So based upon each of those 43,000 chunks, all those chunks are actually going into the large language model, which is the Llama 2 13 billion model. And it's essentially spitting out a corresponding question given that particular context. So this is the prompt that we are sending to the large language model deployed on RayServe. And essentially, it's calculating all those training data sets as well as the validation data set in parallel. So all generation of the training data set and the validation data set is all parallelized using Ray. And as you can see, on 43,000 chunks, this process was done in about 1 hour. And once the particular training test is ready, we can basically fine-tune the embedding model as well using the sentence transformer fine-tuning engine. And the proof in how this particular embedding model works is, if we actually use the GTE-based embedding model, we can see that the hit rate for that particular model being able to search in the vector index was about 62%. But once the fine-tuning was done, this embedding model, the fine-tuned embedding model, is able to find the documents better from the vector index by 18% more. So now the hit rate comes out to be 80%. So this basically empowers how the embedding model would make searching the documents better in the vector index, and that would actually be sent into the large language model to respond in a better fashion. Now, in order to summarize, what you've seen here is we have used a Snowpark Container Services to deploy an end-to-end AI in hours approach. And in this particular approach, we showed how you can build a retrieval augmented generation pipeline in which we not only calculated these embeddings in parallel using the popular open source framework Ray, but we also fine-tuned the embedding model. And basically, all of those models are being served using Ray Serve, and which is a fantastic way to deploy those as APIs. And in terms of cost, it's very favor of cost as well, in the sense that it keeps the cost low because you can do all of this in parallel using GPU 3, which is the lowest possible GPU instance that is available in terms of Snowpark Container Services. You don't really need those heavy compute engines, which is like GPU 7 or GPU 10. So that's the power of using Ray on top of Snowpark Container Services. So let's wrap up on what's new in Snowflake for AI ML. Here's a quick summary of all the features that were announced today on around data science and ML, as well as Gen AI and LLMs. To find out more about some technical details as well as hands-on labs, you can attend Build, which is towards the early December. And if you want to get some access to the private preview features that were announced, please reach out to your Snowflake account team. Thank you so much and have a wonderful day ahead.